Hello friends, welcome to Best Tutor. This is Rama Vishwanathan. In the earlier videos, we have learnt how to find the square roots of perfect squares by prime factorization method, non-perfect squares by long division method. But we haven't found out the square roots of decimals. How to find the square roots of decimals? Can there be perfect square decimals? Yes. How do we find out the square roots of decimals? Let us get into the details of it. So, we are going to learn how to find the square roots of decimals. Let us choose an example. 6.25. This is a decimal. How do we find the square root of this? There are two procedures for that. First one, convert this into a fraction. 6.25 can be written as 625 by 100. This procedure is applicable when you know that this is a perfect square, right? 625 by 100. So, I need to find out root of 625 by 100. I will write it as root 625 by root 100. We can find out the square root of 625 by prime factorization method because we are assured that it is going to be a perfect square, and when we find out the square root of 625 by prime factorization method, we get that square root of 625 is 25 and square root of 100 is 10. So, we have got 25 by 10, and when I convert, this is a decimal fraction, and when I convert into a decimal number, I get 2.5. Therefore, square root of 6.25 is 2.5. So, this is the procedure to find out the square root of the given decimal number when I am assured that the given decimal number is a perfect square. Now, let us move on to the other procedure with the same example. Though I know it is a perfect square, let me find out the square root of this number by long division method. Right? How do I find out the square root of this given number by long division method? The procedure remains the same. We need to pair the numbers, but unlike a whole number, here the pairing starts from decimal point. This is the decimal point. From the decimal point towards the right or towards the left, we have to start pairing. 25. 25 is one pair, 06 is the other pair. In case I have 6.251, then what do? I will write the number as 6.2510 and then pair it. Now, am I supposed to do that? If at all I have 6.251, this is the given number and I have to find the square root of this. I just put a 0. Does this change the value of the given decimal or not? It does not change the value of the given decimal because adding any number of zeros towards the end of the given decimal does not change the value. Similarly, adding any number of zeros towards the left of the number, starting number, does not change the value. So, now in this case the value of the given number does not change and I have made myself comfortable in pairing the numbers. Right. We start with the first pair. The first pair is 6. The perfect square which is less than 6 is 4. 2 2s are 4. We have to be thorough with at least the first 20 perfect squares so that the procedure becomes very simple. 6 minus 4 is 2 and here we need to add the same number and we need to leave away the blank for one's digit. 2 plus 2 is 4. Now, the difference is 2. I need to bring the next pair down, but before that I need to take care of the decimal. This decimal point will not enable us to bring the pair down directly. So, what am I supposed to do? I will put a point here, decimal point here. Now, I can bring the next pair of the number down. So, 225. I have 4 and a blank. Like we have guessed in the previous videos, how do I guess the digit here? 5 is the digit in the ones place. So, obviously 45 may help out. 5 5 is a 25. 5 4 is a 20 and 2 25. Yes, our guess is right. 5 5 is a, so 45 5 is a 225. Right, 0. And here I need to add 1, 5. So, this was only the example, that was an extension to explain how to pair it up. Right. So, 6.25, the square root of 6.25 is 2.5. Right. So, we have learned how to find the square root of the given decimal. using a fraction procedure and as well as a long division method. That fractional procedure will work out when we know that the given decimal is a perfect square. Let us move on to the next example. 32.49. I don't know whether it's going to be a perfect square or not. Let us try. Let us start using long division method. Long division method, first step, pairing up of numbers, and the pairing should start from the decimal point. Right. 32 is the first pair. The perfect square less than 32. 4 4s are 16, 5 5s are 25, 6 6s are 36. So 5 5s are 25 will be a suitable perfect square. 32 minus 25, and here 5 plus 5 leaving a blank. Here 12 minus 5 is 7, and here it's going to be 10 and a blank. Right. I need to bring the next pair down, but this point is stopping us, so I will put a point here and then I bring this 49 down. So here it is going to be 749. I need to put a suitable digit here. 9 is the ending digit. It can be 3 3s are 9, right, or 7 7s are 49. Both these squares end up with 9. So let me choose 1 or 3 first. 3 3s are 9, 3 zeros are 0, 3 1s are 3. It is not a suitable choice. So what if I take 107 into 7? Actually this is going to be a suitable choice because 100 or approximately this is going to be 100, this is going to be 700. If I multiply this with 7, I am going to get a suitable number. That is also a guesswork. So we have got 749. 107, 7s are 749. Right. Therefore, square root of 32.49 is 5.7. And here is one more tip to check our solution. The given question has 2 decimal places. Then the square root will have 1 decimal place. If the given decimal has even number of decimal places, then the square root will have half of that of decimal places, that number of decimal places. One more example. The procedure will be very easy the more and more you practice. 0.4225. Okay. How do we find the square root of this number? 4225. First step, pairing of the numbers starts from the decimal point. Before the decimal point, that is towards the left side of the decimal point, there are zeros. So we don't have to bother about it. 42 and 25 we have paired. What is a perfect square which is less than 42? 5 5s are 25, 6 6s are 36, 7 7s are 49. So we cannot take 49, so we will take it as 6 6s are 36. We should remember that we can never write 6 7s are 42. We tend to do so because 42 is divisible by 6, 6 7s are 42. That becomes normal division and it is not useful for finding out the square root. We need to be very, very careful here. Square root means we need to take only the perfect squares. Right. Now 42 minus 36 is going to be 6, and 6 plus 6 is 12 with a blank for the ones digit, and I bring the next. We made a major mistake here. What is the major mistake here? Directly we have started from 0.42. After pairing there is a decimal point, so we need to start with the decimal point. I am sorry for that. 6 6 are 36, and then we can continue the procedure here. 25. Right. So 1 2 a blank. Suitably hundreds and 600s. So 5 can be helpful here. Reason being, I require a perfect square which ends with 5. So let us try with 125 5s are 5 5s are 25, 5 2s are 10 plus 2 12, 625. So 125 5s are 625. So we have got the solution as square root of 0.4225 is equal to 0.65. Here the number of decimal places are 4, and here the number of decimal places have become half of it, which is 2. Right. These all are perfect squares. Let us choose an example of a non-perfect square and then find out the square root of that non-perfect square decimal using long division method. 27.789. I guess it's a non-perfect square. Then how do I find the square root of this non-perfect square? If it is a non-perfect square, then the square root, the process of square root will not end. It's going to be a continuous process. Let me assume that I would like to find the square root of this decimal up to 2 decimal places. Up to 2 decimal places. This is a condition here. Right. 27.789. We would like to find the square root of it. First step, pairing of the numbers starts from the decimal point. This is one pair, 7, 8. 9 is left over without a pair. Never mind, we can include a 0 here and then it becomes a pair. 27.7890. I have included the 0 so that pairing becomes comfortable. Right, 27. The perfect square which is less than 27 is going to be 25. 5 5s are 25. Blank, 5 plus 5 is 10. 27 minus 25 is 2. And then I would like to bring the next pair down. But before doing so, I have to take care of this decimal point. So I put a decimal point in the square root over there. So I get 7, 8. 1, 0, hundreds, 200s. So approximately 1 or 2. 2 to the 4, 2 zeros are 0, 2. If I try with 3, it doesn't work out because 100, 103 into 3 is going to be 309. So 2s are 2, 204. Now subtraction here, addition of the same digit here, leaving a blank, 104. For 8 minus 4 is 4 and 7 minus 0 is 0. And then I can bring the next pair of numbers down, 7490. This is approximately 1000. I require 7000. Okay, let me try with 7. 7 7s are 49. 7 4s are 28 plus 4 is 32. 3 7 3 2 9. Yes, that's a suitable number. 7s are 7 3 2 9. Subtraction towards the right and addition of the same digit towards the left. This procedure continues. I have asked till 2 decimal places. These are 2 decimal places. But we should not stop it here. We need to continue with the 3rd decimal place also and then round it off. Now it's going to be 7 plus 7, 14, 5, 0, 1, and here 10 minus 9 is 1, 8 minus 2 is 6, 4 minus 3 is 1. So I can bring one more pair of zeros down. Right? I have 10,000, here I have 16,000. So 1 will help me. What if I try with 2? 1 0 5 4 2. Obviously it's going to be 20,000 change. 21,000. Here it's going to be 16,000. So that's not a wise choice. So I have to multiply with 1. I get 1 0 5 4 1. The procedure continues. We would not, even if we subtract and continue, the procedure continues. Now square root of 27.789 is 5.271. But here we are required to find the square root up to 2 decimal places. We found it out till 3 decimal places. Now we need to round it off to 2 decimal places. This is unwanted. So how do I eliminate this? I cannot just wipe it off. I cannot just erase it. If this number is 5 or more than 5, we will add 1 to the previous digit and ignore it. If it is less than 5, we directly ignore it. Here it is going to be 5.27. What if this number is 5.277, for example? Then it's going to be, because the 3rd digit is 7, we have to write it as 5.28. It is more than 5, we add 1 to the previous number and then ignore it. If it is 5.275, then also, because the 3rd decimal place is 5, we need to add 1 to the previous digit and then ignore it. Here in this particular example, we have got 5.271. So the answer is going to be 5.27. So square root of 27.789 is 5.27. So, we have learned how to find the square root of decimals which are perfect squares or non-perfect squares. Initially, we have done with using a fractional procedure. We have to convert the given decimal into fractions and then find out individually the square root of the numerator and then square root of the denominator, and the final answer was converted into a decimal fraction. Later on, we have directly used the long division procedure to find out the given square roots. We will continue in the next video. Thank you.